screen coming up?
Yes, I do.
Okay. Thanks everyone for joining today and continue from yesterday. So quick recap of what comments we addressed from yesterday. I will go over that and I will hand off to Shrikant to continue the rest of the document. So the mainly the one comments we captured is on the Redis DB config. So I'm going to jump onto the config schema. In the device metadata, we added, we removed that server IP and server port. So whether we will use the database config.json.j2 as it was discussed yesterday, and we will it took some enhancement or changes of the code because it has to be generated differently in the control card and line card. Sorry, can somebody mute the? There is a lot of background noise. Thank you. It will be generated in the control card and line card slightly differently because this today this database config.json is generated uniformly in every SONiC instances. However, for a VOQ systems, that the config generation of the database, the VOQ Redis will be running on the control card or a supervisor card. The line cards will be as a clients rather than the servers. So the DB connectors from the line cards will connect to the correct VOQ DB. So with that, we kind of, it's just abstract right now. It's not a concrete config for just for to understanding purpose. So we will have some SONiC platform if else condition, and we define the VOQ Redis instance, and we will either start. We will reuse the same instance or we will start a different instance. Probably that's very specific. We'll skip it, but it has to start it only on the control card. If it's line card, it won't run that instance on the line cards. That kind of config. Then we will have a VOQ DB defined and the ID as 8. I think that's the last ID right now. It is very similar to application DB. That reason separator is colon, and the instance is VOQ Redis. So that's one change from the config things. Other than that, we didn't conclude on the name, so we will continue that discussion after that. Our CPU host communication path and data path communication. That's all from the yesterday's open items. If nothing else is there, we can jump on to the discussing the data path.
Thank you, Suresh.
Yeah, she can go ahead.
Yeah, I'm sharing my screen now. Let me know if someone sees my screen.
Yes, we can see it, Shrikant.
Okay, so we were into discussing option 2. I added some clarifying text that came up in the discussion yesterday to option 2, right? So just to a recap of this, option 2 says do not create system host interfaces for all the system ports in every namespace. Create the host interfaces only for the system ports of that ASIC. And in this latest update, I'm calling it and one additional special host interface. This host interface should satisfy the following conditions, right? Is that packets sent by the host on this interface should not bypass the ingress route lookups, and basically, in general, they should be subject to all the lookups on ingress. And packets that ingress the whole VOQ system anywhere in the chassis, anywhere in the distributed system, it should be possible to send packets to this host interface from that particular ingress point, right? The host interface driver for this interface should be able to classify these packets as being received on this host interface. And in order to stay true to this option 2, there should not be a requirement that the host interface for the actual ingress system port exists. Right. So that's effectively stating the requirements here. And I made comments yesterday saying what our experience has been with SI host interface driver behaviors. The current SI host interface driver behavior is that all the received packets are presented from a SI driver point of view on the host interface of the ingress port. And as of now, if the host interface for the ingress port does not exist, these received packets are dropped. For example, if somebody created a SI host interface of type VLAN, SONiC does not do this today, right? It satisfies requirement number 1 above. You can totally transmit on that host interface and it will go through all the ingress lookups. But it does not meet requirement number 2 that it should be able to receive packets from anywhere in the distributed system without having the ingress port host interface created. Right? We also looked at how VLAN is handled in SONiC today. The VLAN interface in SONiC today is not handled using a SI host interface type VLAN. Instead, it uses a Linux bridge that attaches to the individual port host interfaces. Right. So if somebody wanted to achieve option 2 using VLAN the way SONiC does today, that does not work because it implies a dependency on the host interface for the system ports. Right. Now, we looked at what is the, if we could not use VLAN, we looked at what is the most practical option to achieve option 2. And this is a bit of a detail that's been added since yesterday, is that what we really need is a port that can receive packets on the egress portion of the pipeline and connect those packets back into the ingress portion on the same ASIC. This will satisfy the need that the received packets have a host interface on the same ASIC, right?
So Srikanth, so this is like you're basically talking about a recycle port?
That is an example. Yes, a recycle port could do this. Another option is if there's an extra port. I mean, some ASICs seem to have an extra management port or something on the pipeline that could also do it. But the second option is a little less practical because it implies that you need to have, it has some hardware implications that you need to connect that port to the CPU or something, right?
Understood.
So the most practical option seems to be the first one. If you can connect it back, then it meets both requirements, right? So that's
one question here, Srikanth. So I think the issue with the SI host interface driver, where if you said the packets were getting dropped, do you think that's a bug or it's like
it seems to follow the standard Linux behavior, right? The standard Linux behavior seems to be that if a packet is received, it tries to assign that packet to where the packet was received, not based on where the packet is destined, right?
Correct, but the packet was received on that host interface, right? On the VLAN host interface.
Right, so it's received on the ingress, right? So it tries to find the ingress. If the ingress doesn't exist, the ingress is the port, right? I mean, that's what it seems to find. And even SONiC seems to recognize that today, right? When SONiC does VLAN today, it actually uses a standard Linux bridge as opposed to a VLAN host interface.
Understood. I think SONiC today, you're absolutely right. I think SONiC today, the VLAN interface in SONiC today is using standard Linux bridge, but that doesn't necessarily imply the other, right? The other, I mean, SI standard does support a VLAN type host interface.
Right. What I did not find is any specific rules in SI specification saying exactly how the receive should be classified, right? It's pretty loose there. I do not know if somebody could just look at a VLAN ID, irrespective of which port it came in on, and say assign it to a VLAN interface. The classification, I mean, there's nothing really specific that's saying this is how it should happen, right? I mean, one could possibly make a case that we could add those, but it isn't part of the spec today. I mean, at least to the extent to it's something is concrete there, right?
Yeah. So even though it receives a VLAN interface, right? But today the KNet is not operating VLAN. So I think that's the difference here. From Linux point.
I'm trying to tease out the difference between is this a bug or is this.
So, but I mean, even if you look at standard how Linux has done it, it seems to be that, I mean, you need the full stack. You need the receive port, the VLAN and tunnel and all that to follow the path. And if one of the links is missing, the packets get dropped at the point where the link is missing, right? I mean, it doesn't seem like a bug, but I mean, maybe.
So
maybe
I mean,
people
I
have a
think
different opinion, right?
yeah, like maybe at some point I kind of try to put a diagram together to show what at least we were able to observe. So maybe we can get to that at some point.
Okay.
Yeah, basically it does not find a receive filter and it goes to the default, which is a drop. I mean, that's what we've seen today, right?
Yeah.
Okay.
I mean, at least the driver what we have, or at least the driver, it's not a bug, I would say. It is working as a pure layer 1 Linux driver. And I say layer 1, it's operating at the port level, not necessarily a VLAN or a logical port level, lag or anything. So in that aspect of it, I would not call it as a bug. We could enhance it to do VLAN. In that case, we are moving away from a SONiC operational model, from a Linux driver to Linux bridge driver to a kernel driver, which is today as it just doing a port level operations.
Yes, so you would be relying more on side driver as opposed to the more widely available Linux drivers, right? I mean, that's.
So one question there. So if the side driver, let's say, is enhanced to recognize any traffic coming from each line card to one netdev, like one netdev for each particular line card, and put the package in corresponding netdev.
So you could think of a default netdev that says, okay, I mean, that's the one that if nothing matches, go here, right?
Yes.
And then you would need to build classifications additional on top of that. Or maybe something goes into a VLAN, something goes into a tunnel or other things possible, right? I mean, we are merely stating the behavior as it exists today. I mean, I do not know at this point, if we want to have those behaviors, it's probably best to handle them as specific enhancements. So we can be very clear on behavior we want, right?
My question was like, does it need a side dependency, just a driver dependency? Like
it's more it seems like a more driver dependency, but I guess you would need to be very specific on what classifications you want, right?
Okay.
So basically you need to define, because I mean, I guess a lot of the SI host interface driver code is possibly open source, so you could potentially does not have to be vendor specific. I mean, if you want to build these things, right? You could get it to your default net device and then use a more standard driver after that.
So one more question. So if once we give it to the kernel, doesn't matter where the traffic came on. After that should be fine, correct?
Yeah, it's as long as you give it to the kernel on a net device, I think the kernel might be able to take over. I mean.
Okay.
Yeah, Guhan has pasted something, I mean, interesting to hear that context.
Did you want to talk about it?
Yeah, so I think the you as part of the host interface spec, there's a host table which is dedicated to basically used to classify the packet that received by the CPU to which host interface, right? So there could be a callback function, FD function, physical port, logical port, and L3 dev. I think he says if the host interface type is netdev and ingress if is not a router, then it's sent to the VLAN netdev. So in this case, the ingress dev for what would be the ingress interface? That is in this case on the destination ASIC. What is the ingress interface for that packet?
So when the packet is ejected to the Linux, I mean, or ejected to the driver, it has the source system port information available. So now the natural behavior of the driver is to try and match and find that source, a host interface for that source system port. If that host interface doesn't exist, then I think it's a bit wide open on what we would want that to be, because I mean, at the moment, there isn't an ingress interface because that's not been created, right?
So what I think the host IF spec for a VLAN type, right? If you create a host IF of type VLAN, then essentially that adds a filter, right, to in the KNet driver to say any tag traffic with that VLAN will be delivered to that host IF.
So that is not explicitly the behavior today. So I mean, at least.
Yeah, I think that's just a bug, right? Like the spec point of view, what Gohan is saying is that it's meant to be this way, right? There's a filter, and then the KNet driver can deliver it to any net dev based on the filters.
But wouldn't it change implementations that rely today on whatever the behavior is and attach a Linux bridge on top of that? I mean,
I don't think SONiC creates a host IF of type VLAN today, so I think it's
okay.
not going to impact SONiC per se.
Right. So I guess the suggestion is if we do this, then is the suggestion that we would VLAN in SONiC would be handled using host IF type VLAN as a change, because that also seems like a big change, right?
Yeah, that is a big change. I don't think that is necessary, right? Like this is a special port. This is not I mean, we don't have to necessarily change all of SONiC to use SOI host IF VLAN type, but for this special port, we can do that.
That is. I think, yeah, that is right. So, I think the other way of doing this is also, I don't know if we have discussed, is that basically, you still kind of creating those perceptual host interface using the system port, and on top of that, all those ports, you create a bridge, right? So that is another way of doing it.
Yeah, I think right. The issue there, Guan, would be that you would make an extra hop that you would use the CPU of the Ingress ASIC as a router to relay the packet across, right?
Correct.
Yeah.
Right. I mean, so you would be doing some software routing of packets, which is probably not a desirable thing, right?
And also, like you need to split the host, like a loopback interface, a routing to be separately installed versus the data path routes, right? There will be some routing differentiation because a loopback of a SONiC instance one has to go via CPU, but the data path which is destined to loopback, like then that does not go to the CPU, it goes via hardware. So there is slight changes in there too.
So with all these things said, I mean, there is a practical solution to at least the specific problem we're seeing. I mean, we could definitely explore the thing Guan said. What I do not know is the level of compliance with the side drivers with that specific requirement. I mean, if it's all ready and available, we could possibly experiment with that. But at least with the specific ASICs we've been playing with, there is a practical solution, which is effectively use what Karthik just called the recycle interface, right? So that we have tested out, it works very well. And most ASICs probably will have a similar port that is not exposed to the front panel, but is available for use.
The one thing I like about this one also to add it here that the lag, right?
Yeah.
The lag handling also will be very nicely fit in because there is no further lag net devices need to be created.
So,
agreed.
Yeah, so that's very much. I mean, it minimizes the control plane synchronization for the kernel.
Yeah, I think more generally it kind of minimizes the state you're maintaining for other instances.
Correct, exactly. The DB
the benefit.
Yeah, there will be DB state and the hardware
Yeah,
state.
but I'm saying in the kernel and below is what.
Yeah, kernel and below. Yeah, exactly. Yeah, kernel and below will be very minimal. Yeah, that's what we like it so far. So we kind of recommend this.
So I think maybe what we should do is I think these two conditions are notable, obviously. So maybe we can just table these notes and then look at the next level of detail, because I think it'll also help us cover the option that Easwaran has put together, I mean that we've put together, and Easwaran has some very specific things to present.
Okay.
So I think it'll
So
help us kind of make.
Okay, so we could finish up a little bit more on this and switch to that if that's everybody's okay with that, right?
I think that'll be very helpful, I think, because we have all the options on the table, and then we can make an informed choice.
Okay, so now one of the things that I did add here is I think the tables and the packet flows, I think we can probably come and look at the details later if need be. We talked a little bit about it yesterday, so I don't have any more
Srikanth,
detail.
one thing I want to also reiterate it, we kind of touched on it, but I think it was towards the end. If you just scroll back up to the table, one thing I want to just reiterate, the key aspect is that the MAC address on every ASIC 1 CPU IP is, all of these are ASIC 0 MAC on ASIC 0, ASIC 1 MAC on ASIC 1. And like you pointed out yesterday, the reason is we are treating this as an ingress, effectively an ingress on a front panel port, where it's a special CPU front panel port.
Right.
And we want to perform a routing decision accordingly. Right. And for that to happen, you need the ASIC 0 MAC to.
That's correct.
Okay, fine. I just wanted to clarify that.
That is correct. And this particular option, at least, does not have the problem that we discussed earlier, where the ASIC may not be able to rewrite the MAC if the packet is going to the CPU, because we are going into technically a recycle interface on which we can rewrite the MAC, right?
Okay.
So the ASICs would be able to use different MAC addresses, totally.
Okay.
So that actually may still be an issue with VLAN-based interfaces, even if we solve the host driver problem, right? Just to capture the nodes fully.
Got it. Okay, yeah, that's all I had.
So now the piece that we didn't touch on yesterday here was a bit on the a quick comparison, right? I mean, it's not, I think we've beaten this to death, but just a quick note is net device. I mean, that's the assumption. One of them has a lot of system host interfaces, the other doesn't. Routes in kernel, option 1 needs the full routing table. Option 2 allows for the possibility that we can eliminate a lot of dynamic routes from the kernel, right? I mean, strictly speaking, you don't need all the routes, BGP routes in the kernel with option 2. We may choose to do it because that's how it's done today, but you don't have to. Now, is that part clear to everyone, or did we skip a piece of discussion?
One question here. So, like, if we don't have BGP, the BGP routes, then how does the software stack?
So I think the way you would do this is
into the hardware. Never mind.
Right, you would put a default route in the kernel and point everything to that port, right? And the ASIC takes care of it.
Yeah. Okay. Understood. Yes. That is a win. That is a win.
Sure. I think we still have the front panel ports, right? So
what you would have, right? What you would have is the interface routes, right? Because you need to resolve things like ARP and other things, right? But you just need the interface routes on the front panel ports. Any route that you learn from anywhere, whether it's over the front panel ports or over the ports of another ASIC, you don't need any of them, strictly speaking, in the kernel. You could
right, but I thought you still have front panel ports. Sorry, yeah. So, but you're saying when we go out of our local ASIC, then the local ASIC port, then we're bypassing the kernel routing table as well.
So you can choose to, right? You can
have the
choose if you wanted to, right?
Exactly. I mean, Srikanth, I think we missed that. So this is just optional. We are just comparing what all it can allow to do it, but we are not doing that. I mean,
okay. Oh, it makes sense. Yeah, I get this part. I get that we can do that, but yeah.
You don't have to go that far, but you can do that. And I think one could possibly argue that it's better to do it because then you're handling all host packet flows in a consistent manner, that everything is subject to fate sharing in the data path, as opposed to saying that some host packet flows depend on data path routes and some of them depend on only the kernel, right? So and your ECMP behaviors and lag hashing and everything is very, very consistent if you do this. So just wanted to point that out is that if you want, I mean, option 2 in general provides a path for greater fate sharing between control packet flows and forwarded traffic flows, right?
I suppose the only little quirk with option 2, other quirk, is that the TTL will.
TTL will TTL will decrement.
Actually, it won't.
It won't, right?
No, no,
Only it will, if the destination is in a directly attached network, it will not decrement, right? If it's a directly attached host. If the destination is not a directly attached host, the TTL will decrement.
It's as good as like it's 2 hops from a data path itself, right? Like if you originate from a local, I mean, SONiC 1 instance trying to ping a neighbor connected to SONiC 2, it is actually as good as almost going over a SONiC 1, just that it is going in the data path, right? So it is kind of recycling, as you Karthik saying that like it will be, there will be a path where it kind of, that SONiC 1 software path is done in the hardware.
I mean, so the recycle port changed, right? Does it affect any of the table that we program in the SI? And I mean, I'm just trying to look at the packet flows. Did it change things here, or is it the same?
So it does not change the flows, but what will happen is that the packet will actually recycle and come back to ingress, right? So effectively.
So how does transmission work from the kernel into this special port?
So from a kernel point of view, so I think that picture isn't shown here, but let me pretend that I can use an existing picture to talk about it, right? So from a kernel point of view, right? So let's say, is this the right picture? No, this, okay. So from a kernel point of view, the packet goes into this special net device, right? But when it goes into the ASIC,
is this a host IF in what host IF of type VLAN, or what is it?
So this is the, let's say this is the host IF for the recycle port.
Just like a plain port.
It's like off type port.
Yeah,
okay,
I mean,
got it. Okay.
As a port, let's say you have like 10 ports, you have 11th port, physical port. Right?
Got it. Okay, so the kernel would actually then have to construct all of the headers it needs to send packet out of this port.
Yeah, he thinks that he's sending on the real front panel port, but it's happening to recycle port.
Right.
Okay.
So it goes to the recycle, which means it goes to the egress of the recycle port. But internally in the ASIC, the recycle port is wired back to the ingress pipeline. So it shows up back on the ingress pipeline with the correct MAC, and then it gets routed, right?
Okay.
I mean, I didn't change the pictures to show that extra path there, but I mean, maybe a next update of the document could have it if you decide to go this way. Right?
Yeah, I would
that
put
is
like
an implementation specific detail though, right? As long as
yeah, it's the implementation specific, because if somebody picks an actual port that is connected to the CPU for that, you wouldn't have that, right? So we didn't want to go there, right?
I agree. I think that makes sense, not to necessarily, introduce that.
Right.
I think what you've written makes a lot of sense, which is that you just specify what is the expected behavior of this forwarding behavior of this port, and then let the implementation decide how to achieve it.
Yeah. Okay. So that from understanding point of view, you can say, at least to visualize it, you can say that there is a port, 10 port is in the ASIC, then 11th port is the CPU port, you can call it. That 11th port is actually have external loopback. You can say like a wire taken out and put it back in the same ASIC, right? That's pretty much what we are trying to reuse it. Yeah, but this is, one can really wire it outside or inside.
I mean, the original term Karthik used, calling it an in-band port, kind of is very appropriate, right, in this case. Yeah. So I think coming back to comparison and routing table side
one question I had, maybe I didn't understood, like if the routes are not in the kernel, how will you program the hardware? Like basically.
So I think with option 2, right, we said the routes in the kernel, or at least the tables in the kernel, are different from what's in the hardware. So if you didn't put any routes in the kernel, I mean, the AppDB is populated by BGP or interface manager for interface routes or anything, right? So the database gets it from the AppDB. I mean, the BGP routes are not using a kernel sync, right? I mean, they are directly submitted into the AppDB.
Yes. Okay, so AppDB, and then you just, okay, so you'll not program kernel at this point.
Right. In the kernel, you could just have a default route that points.
I mean, you can. I mean, not just default route. I mean, just to clarify, like that, Shrikant, that we still need a host route to resolve to a perfect next stops.
Right. So you do need the next stops. So you do need the next stops host routes, but you don't need anything else, right?
Exactly. So we will have a PGP peer routes, the peer routes, which is /32 or /128 for IPv6 case, which next stop resolution has to happen from kernel. But beyond that, the route resolution the routes need not be present on the kernel. So it's kind of so you'll have minimal route, not all the routes.
I mean, the big advantage would be that you're staying away from touching the kernel. Anytime you have a lot of route table downloads, I mean, it could be a fairly significant. I mean, we're not suggesting that we should go all the way there, but it does open the possibility.
Okay.
So I had a question. So in your diagram, when let's say SONiC 0 is sending out a packet out of SONiC to a port 1 of ASIC 1. So in that case, when the packet is injected, the destination port will be the recycle port of SONiC 1.
So if SONiC 0 is sending the packet, the injected packet will be recycled port of SONiC 0.
And the destination MAC will be?
The SONiC 0 MAC.
So, but then when the packet gets recycled back, then how will it get routed on SONiC 1?
So what happens is the packet is sent to the destination of SONiC 0 recycle port. And when the recycling happens, it comes back to the ingress of that recycle port, right?
Right.
On SONiC 0.
Oh, so you're recycling on SONiC 0 itself.
Right. Yep. Right. The recycle is right on the local ASIC itself, right? So so that's how the ASIC recycle ports are wired, is that the egress pipeline connects back into the ingress on that same core, in fact.
Oh, I'm sorry. I thought we were recycling on the egress packet processor.
No, so from the host injected packet first goes into ASIC 0, right?
Right.
And because the destination of that packet is set to be the recycle port of ASIC 0, right? When the packet is injected, it goes to the egress pipeline of ASIC 0. And the egress pipeline of ASIC 0 sends it back to the ingress pipeline of ASIC 0, but with a different port context. Instead of the CPU port, it will be the recycle port, the ingress context. Then the recycle, then the routing happens after that.
Sorry, can clarity purpose, can we use an in-band port from here after? Because recycle port is very specific to implementation.
So we could call it in-band. I mean, it seems very appropriate.
Yeah, in-band port is appropriate, and let the in-band port implementation can be recycle or can be a software forwarding or hardware forwarding. So the in-band, there is an in-band port towards a CPU or the local CPU or the local SONiC instance of it, right? Because there could be multiple SONiC instances on the same CPU. So what we are saying is that there is an explicit physical port, a kind of physical port, which is called in-band port connected to the SONiC instance. That the life of the packet starts on that port and ends on that port for any CPU purpose, CPU designated or CPU originated purpose. So that way it's kind of the recycle is sorry to I mean somehow interesting, but just to clarify so that the implementation is not covered.
Yeah. I think in this document we shouldn't use recycle as a term, but I mean it. But right. Basically, we stated the requirements on the port, and anything that meets those requirements is good enough.
So, sorry, one more follow-up question. So if the application on SONiC 0 has to send out of, let's say, front panel port, in that case, we don't use the in-band port, right? We'll use the regular port.
Yes, you would use the regular port. And that's where the question of how the routing table is programmed comes in, right? For example, you could have the route pointing out directly over a local front panel port, and that will work. That's how it does today. But now we open up the option that you don't have to have all those routes and just have a default route pointing to this in-band port, right? In which case,
Sorry. So let's say we keep the current implementation as is for local front panel port,
right.
but for the remote port, we use the in-band port. So then how would the host driver or the application know like when to use the kernel route and when to use the route?
It is based on how the route is programmed, right? So the next hop for that route is pointing to the in-band port, right? If you're going, it's effectively controlled by how you program the next hop and the neighbor.
But
so if you have 11 port, right? The 11th port is the determination of which port to go out is done by the kernel today, right? When you ping a packet,
yeah.
So we decide whether port 1 or port 2. It's based upon the route lookup on the kernel and the VLAN and the layer 2, layer 3 routing, and you pick the destination, the port. So in this case, what we are saying is, yeah, so the 11th port will be picked only for the remote system ports, not for the local system ports. But you could use this for everything. Then in that case, the TTL behavior will change. But we are not recommending that. We are only saying that it's a possibility. Yeah, so the kernel decides that which port to pick based upon the kernel routing table.
Right. So you don't have to decide to remove the routes. You can keep all the routes that exist today, right? Except the next hop for a lot of those routes and the neighbor is pointing to this special port. Right.
Yeah, so I mean, the only behavior change thing I'm thinking about this, Srikanth, that the TTL will change, right? If we change the default route to everything to recycle port, even for the directly connected host, the TTL will be.
I think, so for the directly connected host, it will never change, but a port that is a route that is one hop away from a directly connected host, it will. Right?
Yeah.
So directly connected host, you need to resolve ARP and everything. So those routes you would not remove, right? Because those are interface routes.
Yeah. Anyway, that will go on the front panel port. So if you recycle anything you send on the recycle port, it will TTL will decrement twice.
Yeah. So the recycle, yeah. So it will. So current behavior is if you're sending a packet out from your CPU, the TTL, the ASIC does not decrement the TTL anywhere, right? And if you go through this special in-band port, the TTL will decrement, right? And the way you would probably want to handle this if you decide to take this path is that the interface routes will always point to front panel port so that you're not decrementing TTL for directly attached host.
So this also assumes like we need some driver support for this recycle port. I don't think we have ever used recycle port yet.
So I guess that's why we've been careful about the terminology, right? There's several ways this could be achieved. One option, and that's effectively what the ASIC supports. Question from a requirement point of view, what we're saying is you need an in-band port that meets these requirements, right? A recycle port is one way to meet these requirements. But for example, if the ASIC has an extra port that you want to connect up to your CPU, right? That's an example of an in-band port as well, if we want to go that path, right? So in that case, you're not recycling, you're directly hitting the ingress pipeline, right?
And the other requirement is we don't want to do any processing when that packet is TX'd on that thing, like it should not.
Yeah, the first time it goes to the recycle, it doesn't do any processing. Only when it comes to the ingress of that port, that's when the lookups start happening.
Okay, yeah.
So just for my understanding, in this case, the recycle port is basically another internal service port which is connected to the CPU. Is that correct? You're not doing like a MAC level loopback or something like that.
No, there is no MAC level loopback. It could be totally internal. It's obviously it depends on how a specific ASIC implements it. But yes, we are not suggesting that we do a MAC loopback or a file loopback.
So I mean, in order to put the other way around, we can say that if ASIC doesn't support this kind of recycling or whatever implementation, then we end up asking 2 front panel port to be wasted for CPU purpose.
So I mean, it's ASICs that provide this without burning up, forcing a hardware design considerations generally are more advantageous, right? But that's just an implementation, not a requirement. I mean.
Yeah, exactly.
Yeah, I really think we should not delve too much into the details of ASIC implementations in this context. It's okay for understanding, but yeah, we'll miss other important things if we do.
So I mean, to complete this, effectively, we did prototype this, not using the VLAN, but by this method, and it works. So there is, I mean, option 2 is totally practical and implementable, as described here. Right? Now, we were in the midst of the kernel routing table discussion. It opens the possibility that you can remove a lot of routes from the kernel, but that does not have to be decided as part of this conversation. The obvious advantage is small kernel footprint and greater fate sharing. Right? So I don't think I missed anything on the table, right? The table is there. I don't think we have to go line by line on this.
Yeah. So one thing I would clarify is number of net devices. Or it's kind of, it also lags, right? Number of system ports plus number of lags. Would be the
right. Right. I mean, yeah, we were always kind of somehow thinking system lag as part of the system port, but we'll make a correction here.
Yeah, on the option 1, right? You're saying option 2 is correct. Only local AC. Option
correct.
2, option 1. Yeah, okay. Yeah, that's a lag is important aspect to decide here, I mean, in my opinion, because that kind of helps.
It tends to be a little more dynamic at a host interface level, which we generally don't like.
Correct.
Yeah, when we go for the lag call flow we have in the below document, we'll know that why option 2 is better.
So at this point, do we want to switch to the other option on this host packet flows and then come back to this document? Is that the right thing to do, or do you want to go through the rest of this document?
I think it'll really help to talk about that option too, and kind of have that on the table.
So do you guys want to share the screen, or I have your document open? I can keep it up and you can talk through it if you want.
Ishwaran, you want?
Yeah. Actually, I think so. I realized later that the document that we have doesn't have like the nice flow diagrams that you had and the tables that you had, Srikanth. So I created a similar table. So if you don't mind, I can share my screen and then walk through that table because it's not uploaded yet.
Okay. Let me release the screen.
Okay, so can you guys see my screen now?
I can see it.
Okay, great.
Yeah, I can see it.
All right, so I think it's basically what we already talked about, right? It's just the same idea where it is the net device that we had to create on the SONiC instance is this VLAN 4094, right? A specific VLAN. Pick a number, right? And we were able to create this host IF, and I mean, surprisingly, we didn't have any problems with the SOI driver having the packets delivered to this VLAN 4094. There was one bug fix that we had to fix, but other than that, the net filter worked fine, and so the packets essentially, this is a chip view, right? In the chip, the VLAN is a bridge, and it includes all the system ports that belong to different SONiC instances. You can have like, I mean, like 4.0 and 4.1 line card in place. It's a 2-chip line card, something like that. And essentially all of them belong are added to this VLAN in the chip. This is again, the SAI supports adding system ports to VLAN, and we were able to do that. And then this is the host IF creation for this VLAN 4094.
So this VLAN you created using the way SONiC does today?
No, this VLAN is the SAI host IF of type VLAN.
Okay, and did you have to create the CPU interfaces?
There is no other net device.
Okay, so we've seen a very different behavior in this case. So something needs.
Yeah, we probably have to reconcile. I think we fixed one bug, right? Like that's certainly there. So maybe there is some.
What we had seen is that the packet is dropped unless that ingress host interface for the ingress port exists. And even when it does exist, the received packet is presented on the host interface of the ingress port as opposed to the VLAN. So the VLAN, the VLAN never registered a receive packet for us when we did that.
Here, I think the difference here they have a host IF, SAI host IF. So it means the VLAN is handled in the KNet.
No, but that's what we did as well, right? We did a SAI host IF type VLAN. the receive packet was never presented on the VLAN. It was always presented on the host IF of the port.
But there is, I mean, I guess maybe the difference is that there is no other port, right? Like there is like in.
Yeah, when we did that though, it got dropped actually. So there's definitely some.
We can, yeah, some. I mean, architecturally, I didn't see a problem. Like maybe there's a bug fix, maybe different version of the code, whatever, right? Like from the SOI point of view, this is the model that we tried out, which is one net device that represents kind of the in-band network, and then we added all the CPU sys ports to that VLAN. And the expectation is that when we inject a packet into this, when the kernel or application injects a packet into this VLAN 4094 device, it goes through bridging in the chip, right? And then it can go to any of the other remote CPU ports. And then when it goes to the remote CPU port, it will be delivered on this VLAN 4094 net dev on the other SONiC, and then it goes through the IP stack just as normal. That's what we observed. And I have this other picture similar to, I think, the same table that like the table that you had, and we can actually see how this differs, right? Maybe start with the interface table. In this model, the only sysports that are created, only net devs that are created are for the local ports and for the special VLAN 4094 net dev, which is of type VLAN, right?
Hey, Ishwaran, you might want to magnify this a little bit.
Sorry, I think I went overboard on the, let me see. Yeah. Oh yeah, here. Okay, is this better?
I mean, yeah, I was able to see it good.
Okay.
Now I can able to see it,
yeah.
Okay. Yeah. So I mean, this picture is the same as what you had, Srikanth.
So one question on ASIC0, when you created VLAN 4094, so you created a regular SONiC bridge, and then the only difference was that
this is not a regular SONiC bridge. So this is so it's a completely like a special path in SONiC, right? It's like that's kind of what we have to decide. So this is like it's creating SOI host IF of it's like VLAN 4094.
So basically, you bypass something existing SONiC code to do this.
Correct.
Okay.
So I mean, this is like special handling. This is the in-band network. So we just create this host IF, and then where SONiC comes in is for the member table for this VLAN. It's like the VLAN 4094 sysports have to be added as members. So that's
that L2 part you did via SONiC, but
correct. Okay. But the host IF was not. It was not using the Linux bridge.
Okay.
Right. And I think the difference between this and the option 2 that we saw so far is that I think here the IP address assigned for this guy in ASIC0 is on a subnet, right? It's not like a /32. The idea was that all the IP addresses assigned for VLAN 4094 interface on all the SONiCs will be in the same subnet, right? Like this is an example subnet. We could pick something else too. That's fine.
So
and
did you end up using static MAC records in the ASIC because the SF multicast tables are not standardized as part of SOI, right?
Yeah, so I think let's see. I think when we prototype this, we just let the chip flood, right? Like there are I mean, I don't know, few other system ports. We were just doing flooding and it worked out just fine. But I think we could iterate on it and improve it by adding some static MAC addresses.
Right, because the SF doesn't by default have any flooding records, right? So if you're going over the SF,
what is SF?
The switch fabric, right? So because in this case, unless you directly connected ASICs back to back, the switch fabric has a broadcast table which is not standardized as part of SOI, right?
Well, there are other options that you can like ingress replicate.
Yeah, there are. I think by default, I think it's ingress replicated. I don't think by default when you create switch call doesn't you take advantage of the fabric replication at all, as far as I understand. So, but I mean, those are more chip specific details, right? But what happens in the kernel is that, so this is kind of the interface table. And I mean, maybe going to routing table is illustrative also, right? So you have.
And just add one more. I think once those ARP has been learned, then there will be no flooding, right? So flooding only happens.
That is right. Yeah.
Yes, and even that flooding can be eliminated because we have all the information to pre-program all these paths, like Srikanth said, right? Like you can you can program static arts and static max to like stitch up everything at startup, and then not a single packet gets flooded. Like it's basically, you know, exactly, you'll end up going into the right VOQ, right system port for the right destination CPU, and it's just that it's going to be an L2 operation in the pipeline and not an L3 operation. That's all.
Yeah. So correct. I think so. From the routing table point of view, I think this is how it looks like. So these are obviously locally connected ports. There's no confusion. And then we have the CPU subnet pointing to this next stop, VLAN 4094 in the Linux routing table. And this obviously means the ARP table should have more information, right? So this is where I think you can see the differences. And crucially, so in this example, so the neighbor 1.1 and neighbor 1.2 that's connected to ASIC 1. So we have to install a /32 route in the kernel with VLAN 4094 as the next stop interface. This is done explicitly by some code, right, in SONiC. And this is, I think, similar to the option 1, I believe, that Srikanth, I think you were presenting. And this was necessary for BGP to resolve routes. So once these two are present, other prefixes learned, or I think it's very straightforward how BGP installs them.
So one question is the neighbor record for the ASIC CPUs, right, IP addresses, right?
Right.
How do they look inside? Because I see the Linux version of it.
We don't add them, right? So that's the thing. Like I think here, that's the difference that you pointed to, where the packet coming from this neighbor cannot hit the CPU port of ASIC 0 directly. It'll go like to ASIC 1 and get software forwarded.
Okay, so you're hitting the local network route and then having the CPU relay the packet.
Correct. Exactly. Okay, because the CPU IP, right? Like it's all in the same subnet, right? So it'll first go. So the routing table will basically say just go to the CPU port, right? So,
okay, so you would be doing something special to filter out from those neighbor records from installing into SI?
Exactly. Yeah, that's right.
Okay.
So this is, I think that part worked fine because the neighbor installation, if there is no local interface, it gets filtered out automatically. I think something like that. I have to double check, but that's what was happening.
Now, on the ASIC 1, for example, on the ASIC 1, the neighbor 0/1, the route, so the neighbor 0/1 will be coming as IBGP. Then when you install it, you will be pointing to the VLAN 4094, right?
Right. I think from a BGP point of view, it is happy as long as it has a neighbor. It really is not too picky on how it points, right?
Correct. Yeah. The question is, Srikanth, so you are in the kernel. So your point. So this ASIC 0. So neighbor 1 is dummy. So the packet, let's say the packet received for a neighbor 1/2 on the system port 1 of ASIC 0.
Sorry. Can you tell me like where is the incoming packet?
Let's say ASIC 0 port 1.
Okay, so packet is coming in ASIC 0 port 1. All right.
For the neighbor 1/2, right?
Okay, so it's coming for this IP address.
Correct. Yeah.
Okay. So I mean, I think that would just go through the hardware, correct? Because we would have installed the route in ASIC 0 for neighbor 1-2 /32. This routing in the I think I didn't show the hardware table here, but essentially in the hardware, this will not be VLAN 4094 next stop, right? In the hardware, it will be based on the neighbor table that we program. So for example, if you see the SI neighbor table, the neighbor 1.2 is programmed with sysport ASIC 1 port 2 on an NCAP index that comes over from ASIC 1, right?
Okay, the chassis DB or UOQDB.
Correct.
Okay, so one way the traffic will go or ASIC, then CPU bound, when you ping it, now you are going to send it again. You are putting on the, so let's say you are pinging from the ASIC 0 CPU.
Okay, you're pinging from ASIC 0 CPU?
Yeah.
So can I do one thing? I think in this document, there is also like exactly that scenario here listed. Maybe we can walk through it and then that'll maybe answer more questions other people might have too.
Yeah, okay.
Okay. So yeah, here is the flow, right? So essentially, so I think here we are trying to say I mean, the terminology slightly is different, so hopefully it doesn't throw people off. Essentially, you have two, SONiC 1 and SONiC 2. Here it's called FSI 1 and 2, and then we're calling chassis DB, but it's like really VOQ DB. And you have R1 connected to SONiC 1 and R2, and R2 connected to SONiC 2. And then the VLAN 4094 addresses are this way, and then there is a local port Ethernet 1 here, and an Ethernet 2 here, and so on, right? Like hopefully this is all straightforward. So
I think one thing to note is that this LO0 address is assumed to be globally routable, right?
correct.
It's
So
like
LO0
if you wanted to ping FSI1, you would ping 10.0.7.1. If you wanted to ping FSI2, it would be 10.0.7.2. Correct.
Correct. That's right.
Yeah.
I mean, I think this is similar to all the options that we discussed so far. I think the loopback address needs to be globally routable.
Routable, yeah, okay.
Yeah. So so in this, so what happens first is that like this neighbor comes up, right? And when this neighbor comes up, the 10.0.1.2 is added as a neighbor in the SOI object, and then the SONiC 1 will populate it to the global neighbor table. And then the second thing that happens is that the FSI2, the SONiC 2, it will react to that, and it will do like a few things. So I've written it here, but essentially it will add like a /32 route for 10.0.1.2 here in the kernel, and also it will program the hardware with that ARP entry, right? And then, so once that happens, then when the route advertisement comes for R1, like 40, this /24 prefix comes in, the SONiC 2 can resolve it because it is it'll use VLAN 4094 as the egress interface. BGP will happily install it, and then when the route is installed in SOI, we'll make sure that it uses the correct encap index and everything that belongs to this neighbor 10.0.1.2. And I think that is what, as far as the route installation is concerned. So the ping packet, right? Like when the example is here. A ping packet from, let's say, FSI2 to 10.0.1.2. So from here, if you ping 10.0.1.2, the kernel would basically note that it has to go out of VLAN 4094, and then it would actually use the MAC address of this guy SONiC 1, right? So it will go here to the software, to be software routed in SONiC 1. And from there, then it will get software routed to R1. So it's like extra hop here for the ping packets, for the control ping packets.
So that's a big difference, because the one
that
thing
is a big difference. Yes.
So
So that's the main. Here.
The looping happens on the CPU. The other option 2, what we proposed is the data path takes care of it.
That is right.
Okay.
That is right. So here
that is the main difference, right?
Correct.
That is basically, yeah.
And on top of it, the problem. I mean, the negative I would say is, I mean, CPU is fine. It kind of helps from the tracing the CPUs from a loopback trace path and everything. The biggest concern for me in this case also, that the lag handling, right? The lag will end up having you need to end up creating net devices, right? Because you are not taking advantage of the CPU. So if the packet goes over lag, then you need to have the lag also. Is that correct? Or you don't need a lag?
No, I think the lag is not a differentiator here, because technically if you use the VLAN port, and once you put VLAN host interface, you could keep using it whether the destination is a lag or not. I think that is.
That's right. Yeah, that is right. So I think because the difference is that I think the difference between kind of the two approaches is that one, in this model, right, the in-band network is treated as a bridge, right? Correct. Versus it's a in-band network treated as a router, and that differentiates.
And also software.
What goes in kernel and what goes in the hardware, right? What responsibility is there in the chip versus kernel.
And also it is software bridge there and the hardware bridge. I mean, you can do it in the, I mean, it's kind of hybrid here. One side, your ingress side, you're using hardware bridge. On the egress side, you're using software side, hit onto CPU, then get it out, right? Instead of hardware itself can forward it out. Okay, yeah.
Correct, yeah.
So
I think so. If you just take a slightly more philosophical stance, right? Like basically what this model represents is the fact that we are doing in this from the software forwarding point of view, we're actually doing 2-hop forwarding, right? Which is the conventional multi-chip forwarding model, right? But in the hardware, we are doing this distributed forwarding. That's kind of and we are deliberately diverging these two things is what's happening.
Yeah. Mm-hmm. Yeah. I mean, the data part is some extent when you ping from neighbor 1 to neighbor 1, the TTL will be decremented once.
Right.
Something way. But in case of software, I mean, when you ping from, if you consider this CPU as another neighbor, the FSI1 as another neighbor itself, that also will decrement TTL1. I mean, both cases.
Yeah, I think that is happening in both cases.
Yeah, I do not believe you'll watch a difference by looking at the TTLs. I think fundamentally, in one case, control packet flows are software routed.
Yes.
In the other, they're not. I think that's what it kind of comes down to.
Correct.
Right.
Correct.
So I guess we have seen all the three options, unless there is more you guys want to add.
No, I think this encapsulates it. I think there is more to the document itself, which I think I don't think it's necessary to go over right now, because
right. We could probably finish this topic and go to that later.
I think so. I think yeah, I'll yield the screen, but I mean, I don't know if others have any other questions or thoughts on what's going on here.
So I'm just curious. I mean, did you guys do a trace route on this option?
Trace route, not that I know of, but I think it would work similar to the ping. So we didn't try trace route. We know ping works fine.
Okay.
So the expectation on the trace route would be that the ingress ASIC shows up in the trace route, the egress doesn't. Right.
So like the trace route from a neighbor and the trace route from the CPU, you need, I mean, as I say, if R1, right? Let's say you're doing a trace route from R1 to R2, right?
Trace route from R1 to R2, you'll only see the ingress.
Yeah, this loopback of this guy, right? Let's say this guy is the loopback of FSI1 or the SONiC instance 1. But when you do a trace route from FSI1, you will see directly R2, right? Because you have directly connected almost.
Yes.
That's what you would think like that. But in this approach, you will see FSI2 also in the trace route, because you are actually sending it to the CPU here.
Correct.
So you will see
that. I mean, I think, yeah, that is correct. You're right.
So I mean, the ping, just want to compare. I mean, sometimes it's nice to have.
By the way, I think that might happen with all approaches, right? Like even the other approach will happen.
Yeah, actually, I do not see there is a difference in trace route, because the trace route, the first hop will always be the ingress. But for the second, you will not see the egress, because the TTL satisfies the condition for routability, and you will not see the egress ASIC in the trace route.
Yeah, in the other,
unless you are trying to do the trace route to the egress ASIC itself, or the IP of the egress ASIC, but you shouldn't see that.
Yeah, let me take example, right? Yeah, and this R1 to R2 and FSI1 to R2, right? There are two tables you can compare the trace route. If it both are equal, then it's nicer. But in this case, there's slight deviation. It doesn't really matter. But
Suresh, I think even the other approach, you will get the same thing. I feel like I don't think. I mean, I have to think about it a little bit more. But those may not be the differences here, right? The differences here are mainly, do you want to treat the fabric as doing like a router behind it, or is it a bridge? That's one thing. And how does that? What implications does that have for the kernel programming, and how is it viewed, right?
Yeah,
that's I think more salient.
Yeah, makes sense. Yeah, I'm not saying it's an important point. I'm just trying to compare the output. Yeah. Agree. Yeah.
Yes, I guess
okay,
so probably come to the speak now or hold your peace moment on this topic. We should hear out and see time to probably even make a preference known.
Okay, so I'm going to stop sharing. So if there are more questions, please feel free.
No, okay. 1 second. Sorry.
Oh, yeah. Sorry.
Just a question. So you guys said the lag will okay, the lag will work here because you are anyway hopping up. Okay. Yeah. Okay. Sorry. It will work. Okay. The lag is not because you're not creating a lag state of all you are creating is aggregate net device, which is called VLAN 4094. That is, it will take care of even the lag or any logical port behind it, right?
Correct.
Okay.
Exactly. Yeah.
Okay. Thanks.
Okay. All right. Karthik, do you want to add something else, or did we cover?
No, I'm good.
Yeah.
Any other thoughts? I guess.
Maybe I just add a comment on this. The phase sharing part. Right. So I think one of the difference between these two approaches is that in one approach, the CPU, the line card CPU, when they send out the packet, they are using the hardware entry and to forward those packets. So essentially, there could be more phase sharing with a real data packet, right? So then on the other side, if we send if the line card send a packet to the neighbor on other or not just neighbor, but on any other network that is not directly connected to ASIC, then it has to go to the other ASIC, and then from there, then go there out, right? So effectively, I think, yes, I agree. There is, I think, in terms of the path, I think there is more phase sharing on the previous approach than this approach. But however, I was thinking, in practice, the CPU path phase sharing is not really exercised at all, right? So let's say, I think the purpose of the phase sharing was that, if we do observe some to the phase sharing. So yeah, do we have everybody back? Okay. Yeah.
Well, we have few people missing. We had 19 participants when it dropped. So let's see if we have the.
We have 6 people missing.
Yeah.
Okay. Yeah, maybe I'll.
Yep, there it is. I see Ishwaran also connecting now.
Okay.
We actually see Ishwaran, looks like.
Yeah.
Yeah. Okay. So may I just get to the point that the purpose of phase sharing is that if there's some hardware entry went wrong, if the control plane also share the same the data path shares the same fate, then in this case we can, for example, from the ASIC 0, because it's sent using the directly ASIC 0's routing table in the first approach, then if the ASIC 0's control plane is also trying to reach that packet, reach that destination, then they will not be reachable, right? But I think it seems to me that the control plane is not really exercising those paths. So therefore, even though if the control plane is not exercising those paths, then we wouldn't be able to really leverage that phase sharing so that we can continuously monitor routes and detect if there is a hardware issue or not. I don't know if my point was clear or not.
So I think there are two aspects to the phase sharing. So one aspect is the table state, right? The second aspect is the internal fabric, right? So whether the internal fabric is in the path in both cases, right? Where when packets are forwarded in the data plane from ASIC 0 to ASIC 1, then the internal fabric is involved. And in any approach, like in option 2 and both option 2 and option 3, the internal fabric is involved because you're still using VOQs to talk to system ports and VOQs to talk in between the ASIC 0 and ASIC 1, right? So it still follows the fabric. The difference is that between option 2 and option 3 is that in option 2, if ASIC 0 is trying to talk to a host behind ASIC 1, then the forwarding path is identical to what.
Oh, sorry. Just a reminder. Hey, go ahead. Yeah.
Sorry. Yeah. Sorry. Yeah. So I think the main point is that option 2, the data path is the hardware routing lookup aspect is also covered in fate sharing. I think that is the kind of more detailed version of what you said.
Right. So if you're doing ECMP, or if there is a route that goes missing in data path, your control plane packet would also be affected. Right.
Yeah. Yes, but I think
But there's no control plane going on. I think to be clear, when we say control plane, it's not like you're running a protocol between something on ASIC 0 and something on ASIC 1. All you're doing is ping.
Via ASIC 1, right? We're only running management, maybe SSH or some kind of connectivity to that loopback, but not a control protocol.
That's right.
Via somebody else, yeah. We will run via front panel port, but not via somebody else ASIC. Yeah, some other line called ASIC. So
yeah, it's more like if you're running OEM.
Yeah,
an echo from someone. Yes, if you're running OEM flows, you can achieve better fate sharing because it's all happening in the data plane. I mean, that's the difference. The other difference is the route table size. I guess you can technically eliminate route table even in option 3 in the kernel, possibly. I'm not sure 100%. Maybe.
I have a comment about that part, right? So one thing, without going into too much detail, right? There is something similar that I have some experience with in where we rely on the hardware for forwarding. So what happens sometimes is that, right, you want to introduce some new protocol or do something new, right? Then the dependency on hardware becomes tricky, meaning from the kernel injecting into the recycle port so that you're relying on the hardware forwarding implies for trying something new, you have to have SOI support. Is that not right? Like that's something that I've seen before, but I don't know how directly it applies in this context.
That is, as Karthik saying, right, there is a two fate sharing, right? One is a fabric. In any case, that will be shared, right? Like in both approach. So there is I would say 50% is shared because that fab you're expecting that to be programmed correctly and sharing. The other one you are saying that, for example, VLAN 908, that VLAN specific VLAN is also like going over host IF, right? Specific host IF, which is not existing in SONiC today, but it's kind of vessel treatment. So I will expect something like that coming up in both cases, right?
For example, if you're, I think that is not, but basically the thing that you get is if your NCAP ID is not correct in the data plane. In one case, exactly. you would not detect it with one approach, but you would detect it with another.
No, I understand. Yeah, I understand that part. That's the extra fate sharing that Karthik was talking about. I agree with that part. But about the wisdom of diverging the kernel routing table and hardware routing table, I think
so that is.
I have a comment on that part, right? So, for example, the NCAP ID is not correct. Yes, I think you're giving the control paths that kind of fate sharings, but since the control path doesn't really talk to those neighbors that have running NCAP ID, I think that even though the control plan has given that option, but the control plan doesn't really exercise
so I guess
that
it's not
option.
specifically the neighbor, right? It could be any host behind that neighbor. So anybody.
Yeah, but
I think let's make it concrete, right? Let's say ASIC 0 and neighbor 2, which is connected to ASIC 1, the connectivity broke for some reason, right? The hardware is wrong, right? But there is no protocol running between ASIC 0 and neighbor 2, right?
Right.
So this brokenness in the hardware won't manifest itself in any control plane behavior at all. It'll persist.
Yeah.
You cannot detect it by running a ping or anything, right?
I mean, you will detect it if you are running a ping, but my point is that
not from the CPU, right? If you're running a
you
ping
will
from
say
the
that
CPU of the ASIC, you
from
will not
CPU
detect
part,
that
you will say
fault.
that you were able to ping because the ASIC 1 will do the right job, because ASIC 1 CPU will do the right job, but ASIC.
Yes, the only way you'll detect is if you ping from behind a front panel port on ASIC 0.
Exactly. Yeah. That's exactly, yeah. Instead of that, if you consider that ASIC 0 as a neighbor itself, as I'm behind connected via somebody else, you will not detect it now.
Right. So
Srikant, do you mind like putting up the picture again? Because
yeah,
I think
let me share it.
Thank you.
Let me share the slides. I think. Okay, give me a second. Okay, so let me know if you guys see this.
Yeah, I do.
Okay, so I'm showing the table. I guess I don't have a comparison with option 3.
Yeah, but can you go up to the flow diagram or something so that we can discuss something more specific? Right. Yeah, thank you.
So I guess we can talk with this in mind, right? So if say some server IP or IP in the network, somebody says I cannot reach that, and if the reason for that happens to be a problem in the forwarding tables of these ASICs, you're more like, and your mechanism for debugging that is to go to the router and issue a ping or a trace route or something. You're more likely to detect it with option 2 as described here.
Right. So what will happen is that if port 1 of SONiC 0 and port 1 of SONiC 1, somehow they are not able to communicate.
Right.
Then with option 2, you can go into SONiC 0 and do a ping, and that will fail.
That's correct.
Yeah, but with option 3, that will succeed because it will just go over the control plane to SONiC 1 and then go to port 1.
Right.
Yeah, but I don't know if that is really what we mean by fake sharing
this
here.
is, yes, I mean, it's kind of a question of what other things that you attach an importance to. I mean, the big difference is that really
actually,
you're not. I mean,
no, it's just philosophically. If it, I mean, as Karthik was saying, if you take it philosophically, right, this SONiC 0 is connected to SONiC 1. If SONiC 1 data path is broken, you will expect it to be not pingable, right?
Right.
Iswaran, I mean, that's what I would think like that.
Yeah. But I think we are talking about a case where only the hardware programming in ASIC 0 is wrong, and for the SONiC 1 port 1, right? But yeah, so you can imagine SONiC 1 CPU port connectivity is fine, maybe, like theoretical case.
Correct.
Right. I think the other comparison you could possibly make, we didn't bring it up here, is if you compare it with the multi-ASIC, standard multi-ASIC, a non-VOQ system, that kind of fate sharing is available in that, right? Meaning you go through a greater portion of the data path in that case. And compared to option 3 there, with option 2, you get closer to that kind of fate sharing. I mean, so if you're taking multiple chips connected directly by Ethernet ports using the 4 front end, the 2 back end ASICs, right? In that case, there is a greater amount of fate sharing than we would see with option 3 here. I mean, I guess the question is,
I think
so fate sharing is one, the other is possibly a load on the CPU and other things. I mean, there is an actual dependency that you introduce an extra fault point potentially, right?
For example, SNMP queries, it might be that every other CPU is doing an extra hop for every other CPUs, right? Every other ASICs, right? Like you don't know the routing. I mean, the symmetric routing or asymmetric at this point. You might be that some CPUs are doing an SNMP packet forwarding for somebody else all the time.
I mean, if one of our goals is that we don't want to use the CPUs as routers, I mean, we shouldn't.
I mean, if you give a choice, you agree. But I agree. I kind of agree both works. One thing nice about is like the other one and this one is both solves a lag problem, so that is good. So beyond that is like it's a minor. I mean, it's a very it's a choice.
So I guess is it fair
one
to
more
say,
aspect that comes to mind. Sorry, Ishwan, let you finish.
no,
Sorry.
I mean, I thought, so since we have considered all three, I thought we can at least like firmly say that it's not a great. I mean, we should probably drop option 1. Is that fair to say? Meaning
Yes,
we will not create sysports for everything, and that will imply we have to create sysport for lags and deal with all the complexity. We said, okay, let's not do that. Like that. Is that fair?
Yeah, that's fair. Yeah, I think I vote for not for option 1. So let's remove that option 1 for sure.
Hey, let's just ask again if there is anyone still think that option 1 is on the table. Anyone has preference on option 1?
So I guess the question we need to probably ask is, are people comfortable with either an in-band port or a host interface type VLAN inside, right? I mean, if both of those have not been tried out in SONiC before, I mean, if people have reservations about one, I mean, I don't, but if people have any reservations about those paths, we should. I mean, that's the question.
That's the second question. The first question is, I mean, is option 1 anybody else?
No, I mean, so with option 1, right, it does not rely on any of those. It does not rely on in-band port, and it does not rely on host interface type VLAN or anything, right? It just, and so it's SONiC.
Complexity for lag for sure. That's kind of quite a complexity.
Yeah, it's the complexity is more of the size of the state, not a.
Mm-hmm. So
right.
Okay, so I think probably we can do this. I think I would put a statement here. I'm not in favor of option 1, but I think maybe for now I think we can just focus on the option, the sub option of option, let's say 2A and 2B, and then later just for the due diligence, we can share the pro and the cons, and then just table it for next meeting to resolve that, right? So I think it sounds like I didn't hear any not much vote for the option 1 because of the complexity of those lag and that things. Yeah.
So Guan, one thing I'm also wondering, does this document need to mandate option 2A versus 2B that you called? Like, I think the one other consideration that we spoke about earlier, but we didn't restate, was there are some very specific expectations of the data plane, right?
Mm-hmm.
That we are requiring for option 2A to work. And so if you just kind of take a general view, right? The overall system, VOQ system, can work with option 2A or option 2B, right? And so it doesn't really matter for a given instance, like for a given product that wants to implement this behavior. From a kind of network point of view, it doesn't have many implication, any real implication of which option you choose. The only implication is that SONiC has to support either one, right? Depending on what you can even make it, in theory, make it configurable, right? So
I guess the hardware, it doesn't. I mean, from a software, you do want, you probably don't want to implement two things, right? I mean,
yeah, it's not ideal. I agree.
Right.
But I mean, it's just trying to strike a balance between being general versus, doing something that's optimized for a particular, a particular implementation. That's all I wanted to raise.
Oh, let me see. Yeah, so I guess you're saying that for both options, option 2A and 2B, I think the difference here is not that there's some difference, but on the high level, they are roughly the same approach, right? So in terms of a number of interfaces that appear on those line card, then you're suggesting that the community still remains open on those two options, but I would think maybe we should give some kind of preference. We don't say. Yeah.
That's totally reasonable, and we can debate that further, or we can I'm happy to continue debating, or we can. I honestly don't feel like we can make, especially for the concrete problem we're trying to solve in the one platform that we're trying to support this on. We know that it's going to work, right? So we get to pick based on what we think is the best behavior, and then we can use that as the recommended behavior, and here's the alternative.
Yeah, I mean, one commonality I would like to really add here is that between both option, 2A and 2B, is that both option, here we are only presenting the design of it, but in terms of configuration, there should be something called in-band management addition in both options. In option A, it can use some specific hardware implementation, or like option B, it adds a host IF of SI. And it is implementation at that point, but as such, for the design perspective, there is in-band management port or in-band port that has to be defined, right? So
I had one comment for option 2. So if it's a multi-ASIC scenario or multi-core scenario, do we have to keep track of recycle port for each core?
You'd only need one. You can just pick whichever you want, right? I mean, it's technically, depends on the ASIC, how many such ports it allows. You only need one in-band port.
Yeah, but that is we don't need it, right? At the configuration side or anything. We just define an in-band management port.
So I think you're right. We could define an in-band, a requirement for an in-band port capability, and say the in-band port, an implementation could choose to implement an in-band port one way, like we described here, or could choose to define it as a VLAN based SI host interface. I mean, so that way, from a schema definitions and everything, all you're defining is an in-band port. That is the capture point for your neighbors
so
and routes. Right.
In multi-ASIC scenario, we need one in-band port of given ASIC, of any one ASIC.
Yes.
Right. Every ASIC needs to have one in-band port. Right?
Every ASIC needs to have one in-band port in order to reach that ASIC CPU. I mean, even though it's the same.
So CPU, then basically, it's not like n+1. Basically, it's n plus how many multi-ASIC you have on that line card. The net dev you have to create.
Yeah, and both option A and option B both has to create in-band port per ASIC, right? Basically, we are saying that that's a management port kind of stuff, right? To communicate between CPUs.
Okay, but that is not true with option 2B then. Then basically there's nothing
it's
like
still
that.
the same thing, right? You'd have that VLAN based host interface per namespace.
So VLAN 4094 is that in-band port name of it, but the term we are calling here is in-band, yeah.
I guess Abhishek, maybe the difference you're pointing out is that the in-band VLAN would only be like a kernel net device, but the in-band port would be a real physical thing on the ASIC.
Yes, that is true. Yeah.
Yes. So from a net device point of view, if you're counting net devices, it's not a difference.
Correct.
Yeah. Okay. So I think Gohan is right. What we can do right now that this is getting clearer, we can go back and sketch out fully flesh out this, like for example, this nice tables that Shrikant Suresh have here and the flow diagrams. We can do all of this for both options. And then see how, we pick the name in-band, that's a good one. We'll pick that, right? There's an in-band port approach and an in-band VLAN approach, and let's see how that shakes out. We can discuss this again next week and focus on this topic, I feel. That's my thinking.
It sounds good to me, actually.
Yes, so we could do that, and probably we can capture the terminology in a neutral fashion so that if you want to leave both open eventually, then it's just a difference on how someone chooses to implement the in-band.
Yes, and feel free to borrow from the other PR, like whatever you want. I think.
Yeah, we might take you up on that.
Feel free to do that. Yeah, feel free to do that. I am trying to see what is there logistically. Yeah. However, you copy paste stuff, or I think you have access to the source in the PR, so you can do anything.
Yeah, so we will put a comparison table kind of option. What is the commonality between option 2A and 2B? Because we had comparison option 1 and 2, but similarly we'll put it for that, and we try to keep operational model similar. and only the implementation can differ. I mean, try to see if it's possible. And yeah, I will reuse your document, Karthik. Thanks. So, I mean, should we go to the call flows with this?
So I guess we are parking this specific topic now, right? Should we finish the rest? We do have another 20 minutes or so in the call. Are we people up to going through the rest of the document outside of this topic?
Sorry, I had one question on option 2B with respect to ARP. So, so the ARP request would be flooded, right? In that case, in VLAN 4094. So on a given CPU is I think the ARP packet is like trap and forward, right? So would the ARP keep on circulating?
So I don't think it does, and I'm trying to remember why.
So I didn't fully grasp the question. Sorry, I didn't grasp the question. Can you just repeat that?
Yeah.
So as per my understanding, in SAI, the ARP packet is trapped to CPU and is also forward. I mean, flooded on the VLAN. Is that?
That is true.
So in that case, then when one CPU is generating an ARP request, then would that ARP keep on circulating in VLAN 4094? Because every CPU will trap and then again flood it on VLAN 4094.
Yeah, but it's
but it's not a VLAN. It isn't actually a VLAN, right? It is a host interface. So
no, but in the ASIC we need to create that VLAN, don't we?
Yeah, so you create a VLAN.
Right.
Yeah, so
what is you're going to the other ASIC, you're going to the egress pipeline, right? Where it is not doing further flooding, it's only doing a local replication.
Right. But
so you're not going to the ingress pipeline on the other ASIC, right?
Yeah, so the way it works is, right, like I mean, at least in this one instance, right, the packet is injected into the pipeline to be bridged in VLAN 4094, right? The replication names all the members of VLAN 4094, which is a list of system ports. And so a copy gets enqueued onto the system ports for each one of those members. And at that point, the packet magically appears on VLAN 4094 net device on each of the remote ends. That's it.
Yeah, if you think multi-ASIC, it will in case of multi-ASIC, sure, what you are saying will work like that. But in this case, the replication only happens on ingress ASIC, right? The ASIC 0, for example, if you take it.
Exactly.
So on the remote ASICs, it doesn't hit the ingress pipeline. It directly goes to the egress pipeline.
Yeah.
Okay. Yeah, I mean, I would say it's yes. I think that's a reasonable way to look at it.
Yeah, but on the ingress, on the local chip, if we go through the ingress pipeline again, doesn't get trapped. I mean, if there's a trap,
is it the option 2B or 2A, Gohan?
2B.
It doesn't go through the it'll. So I guess your question is that if the ARP request is going through the ingress pipeline, does it again go to the CPU?
Yeah, local CPU.
It doesn't because I think the chip wouldn't do that. Like it's a source equals dist, right? The packet will get dropped. Yeah. The CPU injected packet cannot go to the CPU again. Yeah.
It's the bridging deja vu check. Yes, exactly.
The bridge. That's okay.
Yeah.
Okay.
So Ishwaran, one thing that would be helpful is with option 2B to draw out, are we proposing keeping the flooding behavior or programming static MAC records?
Sure, I think I can do that. Like, I mean, I think I really like your flow diagram and the table approach, right? So I'll try to create something similar and include some details on how the flooding is going to be programmed and so on. Like I'll work on that also.
Right, because the net device is showing just the VLAN, so it isn't visible at the net device level where the port is, right?
Yes, yeah, that's
So
right.
so if you're creating something, we should just call it out. I think that makes it clearer. And if you're calling out flooding, then just make it clear on whether the switch fabric flooding tables need to be programmed.
Sure.
Yeah, I think we have 20 more minutes. You want to finish this? Let's finish this, Srikanth. The call flows.
Yeah, I mean, it's probably, if people are still available to go through, we can finish some of the call flows. That may be faster than the discussion we just had, right? So. Okay, so let me move past section two, right? We're definitely going to section 3 now. So first one is switch creation. I believe we actually looked at it earlier, right?
Yeah, we had covered it before that. Yeah.
Right. So I think this one's effectively taking from the local config DB and programming it. Tell me which one you want to go. I'll stop there.
We can just go quickly like that. I mean, just for 2
So this is the switch creation. So it's processing the local config DB. Nothing. Switch creation is no longer bottleneck connection to the central database, right? And it gets the system port list from the config DB as opposed to app DB. So when Arc agent is started, it has all the information to go create the switch. Then this one says VOQ system port orchestration. I think this is to show the case if how the Arc agent compares and resolves that it has all the correct set of system ports based on the config, right? So it's got the system port list from the config. It goes to the port arc. Then it does a side discovery for the system port list that were created during the switch create. Once the comparison is done, the expectation is that it should match what was configured. If it doesn't match, the current SI behavior or the Arc agent behavior is to request the creation of entities that are not present in the discovery, or if there are extra discovered, request the deletion. At this point, based on the fact that everything is static, we expect that to match. If it doesn't match, it will fail at that point, right? But in the future, if you do support dynamic, this call flow will get utilized more. Now, the next one is the router interface creation here. Did you want to talk through this, either Suresh or Veda? You want me to?
Yeah, I think I can talk to it. So in this case, I mean, this is for even for so the we really like to synchronize the interface creation, because so the local let's say Arc agent remote creates, when we say remote means which is somebody else ASIC created an interface. That interface is populated in VOQDB because the Arc agent writes to VOQB directly with hardware ID, RIF ID we call it. There are some questions to be talked about. I will not bring it up right now, but let's say there is some IDs here, because when interface is created over a lag or created over a VLAN, that information has to be passed, because that exact, when we create the RIF on the local, it has to have the attributes to know that which this interface is created over VLAN or a lag or port. Assuming that we synchronize that state, the interface can create it on the VOQDB first, populated VOQDB, and the local Arc agent picks that, then checks for existence of port for the interface. So this port is the one question here. This port can be type of lag or VLAN. We have to take care of that. Once we take and then we get the system port ID, then we create the router interface on the ASIC DB as usual in the call flow. Yeah.
Okay. So next one's the neighbor. So this is dynamic, right? The system port router interface creation. This is not static based on config.
Not config. Exactly. That's a correct question. Yeah. I mean,
so the question I have here is that, I mean, is it for future use case, or, I mean, today it's.
So I guess what we're saying is that the system port list should be in the config DB locally, but the router interface creation on the system port, there is no explicit expectation from SI that it be statically provided, right? So the way we put it here is that we are allowing the other ASIC to present the system port interface, and then we create it on our side.
But is there any dynamic information though? I mean, that's where I was.
So there is at this point, there isn't anything dynamic other than someone deciding that they don't want to create routing interfaces on all their ports, right? Because they may have the ports, but they may have only at that point routing interfaces only on a few ports. If they want to go back and add more later, you don't need to change the config of all the ASIC. You can just work with the ASIC where it's, and then it propagates.
No, the other option is I mean, if the expectation is that the interface to be configured statically across all the ASICs, I mean, that's a nicer. I just want to check. Yeah, I mean, we had that same thought, but we thought neighbor is dynamic and interface also can be dynamic. System port eventually will become dynamic, right? Like when we dynamically add and insert it. If everybody agrees to do a configuration of the interfaces across all the ASICs, even though that interface doesn't really belong in that ASIC, I think that would be a nicer option actually.
Yes. So we didn't put it in the config DB on all the ASICs, right? We just said this could be dynamic still.
Yeah. Yeah. So any comments on that from anybody else?
So in a world where we already decided that all the system ports would appear in every FSI's config DB, right? We already decided that, and presumably down the road, then all the global lag state would also then appear there, like our lag configuration would also appear there across the device. So I don't see any reason why, at least for this initial version, we treat layer 3 interface specially. They all kind of go together, right?
Okay, so it means that we will create a system port as a config, interface also. Interface, of course, a config. The question is whether it is a global config or a per ASIC config, right? Per instance config. If it is treated as a global config, I think it works very well.
So again, I want to be a little careful about what I said. Like what I meant to say was, under the assumption that we are going to represent the global configuration of system ports on the entire system, right? In the config DB, right? We will also, and similarly for lags across the system, then I don't see why the layer 3 interfaces is any materially different in any way, at least based on, I don't see, if we just kind of scope it from an initial scope of, we want to support static configuration based VOQ, distributed VOQ systems as a first goal, then I don't see any reason to make this special. That's all.
Okay. So I guess the one comment I would add is, if it turns out from a SI implementation point of view that there is a hardware ID that they want to carry from ingress to egress representing the interface, we would need to change this answer, right?
At the time we can change it, but for now,
correct.
Yeah. So I mean, only thing is
precluded, of course. Yeah.
Right.
So whenever we add a local interface, it means that every ASIC on the chassis has to be configured again, right? Like that's where we thought like it could be a little bit overwhelming, but it doesn't hurt because probably that's not operational model. So dynamic. Like for example, I mean, if you change if you add one interface on a layer 3 interface on a one ASIC, it means that the configuration. I mean, now the config has to be changed on every other ASIC. It's not a problem, but I just want to bring it out. I mean, I think you.
Let me chime in. I think so. There is a difference between the router interface, the lag, and the system port, right? So I think the system port only changes when we, let's say, changing the adding a new line card, or replacing a line card with a different port count, right? So at that time, the system port will change.
I think I mean other breakout will change it too, but yeah.
Oh yeah, sure. Yeah. Breakout will definitely change. That is kind of like a physical topology change. However, I think in our provisioning model, right? So when we provision our chassis, we first put the chassis there, but we're not connecting all the ports. meaning that we're not assigning all the IP addresses for every line card port. And so what happens that we don't change the physical, once we put, 4 line card there, then we don't change that physical part, but we will later add a new, in this case, the clusters under that T2, then we add it. At that case, we're going to, change your unused port to a router interface or port channel. Okay. So I think there's a this kind of a difference, that meaning that initially we coming from the mini graph, it has all the system port available, but doesn't mean that all the IP address, all the ports are used and all the IP address are configured.
Okay, that's good to know, because that so I mean, based on that, I think then the answer is clear, right? Like what we should do.
Yeah.
Right. So you may create a lag later. Is that what you said?
Yeah. Yes. We may sign up, create a lag and sign IP address on the lag later.
Okay. Yeah. So we'll keep this then. We'll keep this, right?
Mm-hmm.
Okay.
Yes. Yeah. If that's the case, we should keep this. Yeah.
Yes. I think that this we should keep. Yes.
Okay.
So the next one's the neighbor
one question
creation.
on the router interface. Let's say I'm creating on ASIC 1 or like line card 1 router interface. At that time also I will use my local port, or I will use the system port for my given ASIC.
So the config model, what we are thinking is you'll use a local port, but based upon that, we will able to push that to mapping with the local port to system port, because that's a question I had asked in the beginning of the config schema. So the ARC agent remote, the first vertical flow here, will know that which system port is the local port, the interface created. So we don't want to change the single ASIC configuration model. So we let it create it, but as long as there is a reference from a system port to local port, association has happened.
Okay, so for a given line card where we are creating, that will be local port, and then rest all the line card will use system port.
System, yeah, that's what at least what we thinking too. Yes.
Okay.
So the VOQ neighbor creation, Shikhar, can you get a little bit more?
Yeah. Okay.
Yeah. So here, if you look at that call flow perspective, as currently in SONiC, so the kernel discovers the neighbors via R packet resolved. The kernel populates it in the kernel R table. Then the neighbor SINCD, which receives the netlink event, then creates the appdb information for the neighbor. That neighbor information is picked up by the neighbor ARC on the ARC agent. At that time, it creates the ASIC. Let's say it creates ASIC DB, then completes a SOI call. After SOI call completed, now it gets the hardware, the NCAP ID. With that NCAP ID, the only thing it has to do is push that to VOQ DB with the neighbor table entry with the NCAP index.
So this line here I'm moving an arrow on is the new line, right?
Yeah. Other than that, pretty much the rest of things stays as it is.
So this is for the local.
Yeah, this is on the local when the local RP is resolved. Yeah, local neighbor.
So let me go to the remote.
Yeah, so in this remote, so the same neighbor, now it has to be discovered on all other ASICs. So the ARC agent already published to VOQ DB with NCAP index. That VOQ DB, picked up by all the ASICs ARC agent. So we call them a local ARC agent. At that time, then it calls the ASIC DB, or basically pushes the information to ASIC DB with NCAP index. So in this case, a system port ID rather than we can call it ref of the ref index or a router interface ID of the system port, because the neighbor created on top of router interface rather than the system port. So we create that to a ASIC DB so that SINCD creates everything. And that's normal addition of as neighbor. Once that neighbor addition is done in the SINCD via SOI, and it comes back, the neighbor ARC adds a static route. So this is only added via ARC agent to the kernel if a switch type is VOQ. So that's another additional code change, and the design of it. So if you can, she can highlight the last box.
This one here.
Okay,
yeah. So this is a case where the ARC agent is adding kernel entries.
Yeah. So in this case, it has a MAC address and everything. So we will populate with the actual MAC, though it is not necessarily used, but just for a sake of consistently.
I guess to complete the conversation, depending on which of the options we pick, we'll always create the ARP and the host route, but we'll put different information for the net device based on which of the three options we pick. Right?
Correct. Yeah. Let's call the port. I mean, the port
Right.
name is in-band port or in-band
Right.
VLAN. We'll decide on that.
Okay. All right.
Okay, then, any question on this? Otherwise, we can go to the next one. So the port channel is again it's a dynamic configuration driven. It's not a kind of given at the boot up time or a startup time. So as we discussed now, so the ARC agent, let's say the port channel where it belongs physically, or the owner of the ARC, owner ASIC, ARC agent creates a port channel on the local call flow as it is today. Nothing changed on that. After that, it pushes that port channel with we are creating hardware aggregation ID. There's some IDs which we need to retrieve it. This could, today, so this is, we are calling, in the design perspective, we are calling hardware aggregation ID. So it could be hardware, or it could be that the ID to represent from a globally to address it. And that ID is pushed to VOQDB, and every other ARC agent, the local ARC agent picks that, then completes the SAI call flow as it is today with using that hardware ID, which is very similar to neighbors.
So, but Suresh, I think this has actually been standardized in SAI. Instead of calling it hardware ID, they're just calling it a lag ID, right?
Oh,
and
yeah.
the lag ID during the SAI calls, it was agreed that it could be application assigned.
Yeah, we'll update that. Sorry, yeah.
So I think instead of calling it hardware ID, we could call it a lag ID, which is application controlled.
Yes.
So one question is that does that mean the port channel table is going to be in the VOQDB or chassis DB?
Yeah.
Because
so there is a VOQ. Yeah. If you go up on the, Shrikant, if you go up on the VOQDB, we have put three tables: interface, neighbor, and port channel members, all the way up. If you can go, probably. Maybe you can go to table of content and click on it. Yeah, here, right here. Yeah, schemas. Yeah.
Sorry, yeah, we skipped this earlier, right? So that's fine.
Yeah.
Okay.
Yeah. So the VOQDB has neighbor, interface, neighbor, right?
So interface is now, it's dynamic, right? It's not okay.
Right.
It's okay, and then but the system port channel is almost like a configuration. Is that right?
Only system port is config. Only the one thing we removed from my VOQDB is system port. It is in the config DB and doesn't changes if only config changes it. But rest
so
of
there are two tables for port channel, right? One is the system port channel and the system port channel member. Apparently, this SONiC does two tables for that today.
Yes. So
That's
the question that I have is that the lag ID has to be globally assigned.
Right.
Correct? And does it make sense for this to be in the config DB? Is it similar to sysport in that sense?
Right. For the local ports, it should be in the config DB. Yes. Otherwise, you cannot create it, right?
No, the lag itself, the lag ID is a globally unique, but we thought it's a hardware specific on that ASIC, right? Because it derived from hardware, right? So it's a local.
No.
It's assigned to the hardware.
So in the size discussion, Suresh, it was agreed that application assigns this, and then just like we manage system port IDs, the application has to manage the lag ID globally.
Oh, okay. Sorry, I missed that portion. Yeah. Okay. If it is
it's a little bit unclear to me how
even though it's a globally assigned. Sorry, I will take back. Even though it's a globally assigned, the config event itself can happen a little later. So we want to synchronize via VOQDB, right? So yeah, the lag ID will be there in the config DB, but it will be picked up by the ARC agent and pushed to a VOQDB as a more like a dynamic synchronization point.
So I guess section 233 potentially could be in the config DB, but the member table has to be in the VOQDB, right? Because you don't know the exact members.
Correct. That makes sense. That makes sense. Like that's what I was trying to refer to. Like,
okay.
No, even then, right? It can be in the config DB, but we just talked about for interface. Since that the interface addition can be happening a little later, we are not going to configure every other ASIC, right? So
right, you're right. Right, you're right. So basically, you don't want to put it in your interface because that lag could be created much later after the switch became
much later and only on that particular SONiC instance.
Okay. So then what we should be saying is that the config DB that we use for the local lag members should have the lag ID.
Yes, yeah, the local ASIC will have, I mean, the ASIC, the owner ASIC will have it. The local ASIC will have it.
I think this starts to get a little interesting. Like this whole, like even configuring layer 3, I'm just thinking aloud, and maybe this will spill over to next time, is starts to get a little interesting, right? Because now are you going to, when you add a lag, what's the preference? Like if you want it to be in the config DB, then you have to go and hit the config DB of every instance, right? Like, or the other option is to look at, there's a kind of system-wide config DB and you put it there and it's visible to everyone. I think there's still some uncertainty around what is the better approach.
So yeah,
just interest of time, I think it's 11 o'clock. So I guess it seems like an interesting topic and we need to spend more time to discuss it. Yeah, I haven't thought about this application sign lag ID. So do we have this continue on next Wednesday, the same time, 9/11? Is that
we can do that, Gohan, because at the SCI meetings there's no agenda for the SCI community call, so we can potentially use the 9 to 10 or 9 to 11 on Wednesdays.
Okay, is everybody okay with that?
Yes, so tentatively we're meeting next Wednesday and possibly Thursday as well, right?
Yes.
Right. We'll keep our meetings as is, and in addition to that, we are getting this Wednesday slot because SCI community meetings are no longer, there's no agenda for this.
Yeah, I think it's, I mean, this 5 hours this week is really helpful. Yeah. I think we get a lot of questions clarified. I want to keep this momentum and then get rest of the, the design iron out. I think that is purpose.
Okay, so we're going to do a 2 hour on next Wednesday or just a 1 hour?
The 2 hours, 9 to 11, I'll set that up.
Okay.
Yeah.
Okay. Yeah, works for us.
Yeah.
This has been really productive this week. We'll continue the momentum next week. And I'll send out the recordings and the notes as well for today's and this week's calls.
All right. Thanks, guys.
Thank you, everyone, for joining. Thanks for the time. Bye now.
Thanks.
Thanks, bye.